Good morning, good afternoon, good evening. Welcome back. This is day 4 of FLUOROS, and I have a quick few regular announcements that might start showing, and they are on their way somewhere. So this is again for those live in Providence. There's fire safety rules, know your emergency exits. The code of conduct is part of the packet. So far everything is going well. We don't expect this to differ for the last 2 days. There's copyright, and the speakers of course only present their own views, not their funding agencies or sponsors or ours. And of course those that are here, stay safe. So far we've been doing well. All the tests have failed. We're good at failing things, so that's great. We continue with the land acknowledgements that we gather on traditional lands of the Mashpee, Niantic, and Narragansett people. We honor their histories, ancestors, and perseverance as our country was built on their land, acknowledge the indigenous people, and honor the stewardship of the land, sea, and resources that they hold sacred and that we shepherd together. So with that, we have to say big thanks to the Toronto team, Toronto plus Pierre and Chris. So that was a very excellent morning session yesterday. And then Yitka and Carrie for working behind the scenes to make the poster, judging a success. Then of course the Brisbane group, Carl, Jen, Jochen, and at times Lutz. That was a very nice session and discussion, and we appreciated the humor while there were some minor tech issues. Anna and Mark for moderating throughout the day, and Mark for nicely finishing it off with a nice discussion with all the Australasian participants. And of course, the local staff for making everything happening. So with that, yesterday was Judgment Day. I believe most scores are in, so big thanks to 30 judges that looked at the posters, sent in the scores, and we'll hear the outcomes hopefully tomorrow. And with that, big thanks from my end, because now for the rest of the day we'll have either a group in Brussels or live presentations in Providence. So we have a big day that's focusing on the biomedical and the toxicology side. So we switched from what we did yesterday, which was more on the environmental, technological side, to the human and the toxicology side. So we're looking forward to a very long day, and we're very pleased to have HBM4U have the morning session from Brussels live, or their afternoon session live. I wish we could share some of the chocolates that I'm sure you have. And Jared Liddy from Harvard School of Public Health will help with the moderation. With that, I hand it over and wish everybody a wonderful morning, afternoon, evening. Thank you.
So thanks again. So welcome to this session on human exposure to PFAS, a threat for our health, hosted again by HBM4EU. So this is a session in which we'll hear from several experts on a wide variety of topics in the epidemiology, biomedicine, and risk assessment spaces related to the exposures to PFAS and the related health effects. And for those attending remotely, please post questions to Hova, and I'll be moderating those as the session is going on. So first, I want to introduce our chair, Dr. Greet Schoders. Dr. Schoders is Program Manager of Environmental Health at VITO, the Flemish Institute for Technological Research, and Professor at the Department of Biomedical Sciences at the University of Antwerp, where she also coordinates a master's program on environment and health. She's committed to initiatives for accelerating the transition to a toxicity pathway-based paradigm for chemical safety assessment, and was also president of the European Society for Toxicology in Vitro. And she's also a member of the Scientific Committee of the European Environment Agency and of the European Scientific Committee of Health and Environment Risks. And so I'd also like to introduce Dr. Maria Uhl. Dr. Uhl is toxicologist and risk assessor. She's the head of the team studies and consulting at the Environment Agency Austria. She's also coordinator for the Austrian Platform for Human Biomonitoring and chemical group lead of PFAS within the European Human Biomonitoring Initiative. So now I'll pass it off to Dr. Schoders and Dr. Uhl for more introductions.
Like to say to all the colleagues online hello, hello from Brussels. Good morning to our American colleagues. I hope also the Asian colleagues are still there. It's for us very nice that we have the opportunity to have this session organized in Brussels to be the European hub of the FLUOROS conference. It's a great opportunity to discuss the new insights, which are definitely needed, because also in Europe, here we are facing many problems and concerns on PFASs. This session is organized under the umbrella of HBM for EU, and I would like to present you very briefly in the next minutes what HBM for EU is. I think I can get the slides on the screen. Yeah, I can even get the slides. Well, it's not me, it's thanks to technical help. We have the slides here. So I will chair the session together with Maria Uhl. We are both part of HBM for EU, the European Human Biomonitoring Initiative, which is a very big project that has been organized in Europe. 30 countries are participating together with the European Environment Agency. It's a project which runs for 5 years. It will come to an end mid-2022. It's paid jointly by the Commission and also by the funding partners, by the countries. And a lot of scientists are participating. In fact, we have 120 institutes that are partner of this big project. And the main aim is to establish a human biomonitoring network in Europe. But I will tell you a little bit more about this project, because it has a unique feature that it really wants to make a bridge between science and policies. First of all, we captured the policy questions from the authorities, from the EU authorities, and also from the authorities in the different participating countries. Second, we want also to give fast and answers to these policy questions and to provide easy access to results and data. And third, we think the communication on the results and on the way how we are working is essential, not only to the policymakers, but also to the public. So the project, the big project is organized in 3 pillars. So we have one science policy pillar, which really tries to make the bridge between science and policy. This means capturing what needs to be prioritized with respect to research activities, and also how the results of the research activities can be used by policymakers. The second pillar really is dedicated to establishing this human biomonitoring network in Europe, where we try to get a good view on the environmental pollutants present in European citizens. And the third pillar is more research-oriented and focuses on the link between human biomonitoring data and sources, and also the link with health effects. So I would like to show you also that we have, thanks to the input of at the national level and the EU level, we have been able to prioritize a number of chemicals and chemical groups that are taken on board in the research in this project. And you see we have already 3 rounds of prioritization. The perfluorinated compounds were already prioritized in the first round. We also recently organized a 3rd round of prioritization in which 25 substance groups were again prioritized for further research. And that will go to the next initiative, because HBM4U will end in 2022. But we are very happy that a new initiative, much bigger initiative, PARC, will start. It's a partnership for risk assessment of chemicals in Europe, and it will not contain only human biomonitoring, but also toxicological research. All will be taken together to improve the risk assessment of chemicals in Europe. If we look at the HBM network, which is being established, then the principle we have taken is that we are building on existing experience in the different European countries. So many countries had already their human biomonitoring network. So we have harmonized this to the extent that that is possible. And about 25 countries are participating and bringing their human biomonitoring networks together. We are focusing on 3 age groups: children between 6 and 11 years old, teenagers between 12 and 19 years, and adults between 20 and 39 years old. For each age group, we have about 10 to 11 countries that are participating and recruit a sample of the population for that age group. And they are harmonizing the procedures. We also have built capacity in Europe, laboratory capacity, to be able to measure biomarkers of exposure in different laboratories in Europe. 28 countries, laboratories from 28 countries are involved, and a lot of emphasis is on building quality standards, on collaboration, and on exchange of information. So we have more than 74 biomarkers that will be measured, not all in all laboratories, but there is a good participation of many laboratories in many countries. And the idea is that we can come up with comparable data so that the toxicological data that we obtain are really comparable between the laboratories. Next to building the analytical capacity, we have also we are also collecting data, existing HBM data, human biomonitoring data, which existed before HBM4EU, are brought together in a big database, and this database is accessible via a dashboard. The dashboard can be found on the HBM4EU website, and it contains a lot of data sets from European studies on a number of biomarkers, and it's searchable. It contains summary statistics, and you can easily access them. You can select for the biomarker you are in, the chemical group you are interested in. You can select for the biomarker you are interested in, the age group you are interested in. So the data are.
Ironically, when we thought that we would have a really easy technical day, we had just lost connection to Europe. Maybe that's part of the Brexit trouble. So we'll quickly have Philippe Grandjean, who is not physically in Brussels, so he is actually on. He is our steep moderator for this morning's or afternoon session, so I think he'll karaoke till we have connection back. Philippe, over to you.
Okay, I hope I'm on. It's very nice to be part of this experimental FLUOROS conference. And since we all work on experiments, having this going on at a scientific meeting is really the peak experience, for at least for me. So I'm very happy to introduce the first speaker who's not present, but who recorded this a while ago. I think that he is introducing himself. Alex or Jared, can you put on the first video? The video is named Grandjean, I believe.
Good afternoon or good morning, as the case may be. I'm happy to join you, although it's just going to be via my computer screen. The focus of my talk today is the importance of early life exposures to PFASs. And, you know, when you do a risk assessment, what you need to figure out is what is really the concern here? What is the key outcome? And what are the predictors? And what I will focus on in the next 20 minutes or so is bone formation in children, vaccine responses and lipids and their metabolism. And clearly, when you focus on those outcomes, you have to figure out what is the population at risk. And also, you, of course, want to measure the PFAS exposures so that you can identify the dose dependence of the outcome, and then you decide on what to do about it. But there's an issue here, which we oftentimes tend to forget, and which I think is crucially important, and that is, nota bene, the timing of the exposure. We have to choose the time where we identify the suspectedly causative exposure. And this slide here, which is from the European Food Safety Authority, illustrates the great importance of the choice of the timing. This is the serum PFOA concentration, which has been modeled in a female. And you can see it starts at a very low level from the transplacental transfer, and then it goes way, way up, almost like a tenfold increase that we've seen oftentimes. And that is, of course, due to breastfeeding. And then it drops down again as the body increases in size and dilutes the burden of the PFASs. And then you can see there's an age-associated increase and accumulation. And clearly this woman never got pregnant or breastfed, so there are no decreases associated with that. We can't see the impact of menopause. But anyway, the key is that there are great changes in the serum concentrations in early life. And we therefore need to figure out how do we best determine the PFAS exposure. And clearly they change over a lifetime. And we would have thought that because the long half-life of PFAS is in the body, that the serum labels would be stable, but that is not quite the full truth. So the question is then, should we just measure the PFAS when the outcome is diagnosed? But the problem is that cross-sectional studies can be misleading. And if there is a misclassification of the exposure, it can, and oftentimes does, lead to a bias toward the null. So the big question is, should we then just measure the PFAS concentration in the serum at the peak, or is there some time or age of the greatest vulnerability where we should try to get a blood sample and measure the PFAS concentration? Now, we've done some studies in both cohorts from the Faroe Islands, and you can see the Faroes here at the very top on the left. They are a population of a little over 50,000 people, and for various reasons, they are highly suitable for environmental epidemiology studies. And here, this is a picture from NASA, obviously, and just below here is where the laboratory at the University of Southern Denmark is located. So we're seeking answers from these birth cohort. This is our birth cohort number 5. And as you can see, we got blood samples from the umbilical cord, and we got blood also at 3 different postnatal examinations. And the outcomes, of course, as I've already alluded to it, is that we looked at bone mineral density, vaccine antibodies against toxoid vaccines, and we also looked at cholesterol and triglycerides and adipokines as biomarkers of lipid metabolism. Now, let's first look at the mineral density. And here's an illustration from Annalisa Blumberg's paper that she developed while being a postdoc at Harvard School of Public Health. As you can see, this is bone mass density at age 9 years. And this is on the right, this is the cross-sectional association with the 5 major PFASs. And you can see PFOA strongly turns out as a predictor of lowered bone mass at age 9. But if you look at the exposures as measured in the cord blood, there's nothing really there. So it doesn't look like it's developmental. However, if we look at the previous blood samples obtained from the cohort, we can see it's not just at 9 years something turns up, but it's also at 5, and actually 2 additional PFASs turn up as predictors of decreased bone mass, 2 additional ones at 18 months. So apparently something is going on early in life here at 18 months, and something else is actually happening later on during childhood. So this illustrates to us that perhaps the PFASs, the different PFASs, have different profiles of age-related vulnerability. I will now move on to the vaccine antibodies, because this is something we've looked at for over 10 years. And clearly, vaccine antibodies are stellar indicators of immune system functions. It doesn't tap into all of the functions of the immune system, but it does reflect the joint outcome of T cells and B cells, and of course plasma cells. And it has the advantage that all of the kids have been exposed to exactly the same type of antigen at the same age, the same dose. And it's a routine measurement in the hospital setting of the vaccine-specific antibodies. So when we first looked at this, this is a paper that came out in JAMA. This is the diphtheria. And what we do here is, on the horizontal scale, is to look at the PFAS exposure at age 5. And here in the vertical scale is the diphtheria antibody 2 years later. And the kids did receive a booster dose at age 5. So they should be doing quite well 2 years later. And you can see at higher exposures, PFAS exposures, there is a loss of about 50% of the antibody concentration for each doubling in the exposure. And both of these scales are log. So we wanted to look at this in slightly greater detail. And here again, you see the associations for tetanus and diphtheria with a doubling of the serum PFAS. And this is the structural equation model that uses both PFAS, PFOA, and PFHXS to combine into a joint exposure, a latent variable that we then relate to the 2 vaccine antibodies. And you can see they're not different. The numbers are slightly different, but statistically they're not different. So you can merge them into a joint loss in vaccine antibody. Here's the confidence interval. And it's about 50% for doubling. But when we then decide to look at both the H5 and the H7, this is what we get. You can see it becomes stronger when we rely on both exposure assessment. So it's clearly better if we rely on more than one serum PFAS analysis. But we wanted to go even further back in the child's history and PFAS exposure. And we didn't have blood samples from the early times. So what we did was to try to estimate using the information that we had on breastfeeding. So what we did was to try to see if we could predict the age 18-month serum concentration of the PFASs based on what was in the cord blood, because that's how the child started, and the duration of breastfeeding, both the exclusive breastfeeding, the partial, and the non-existent during the first 18 months of life. And so you can see here that the horizontal scale, this is the observed PFAS concentration in the serum, and the vertical scale is the modeled using the information on breastfeeding. So this worked quite well. So we had confidence in the algorithm, and then went on to calculate what would the concentration be at 3, at 6, and at 12 months of age. And this is what we found for tetanus and diphtheria. For tetanus, we actually see that the calculated concentration at 3 months is better than the prenatal. The numbers for diphtheria are lower, but at least you can see that the 3 month and the prenatal are somewhat higher than the numbers from later in infancy. Now, these ages are crucial, and I'll come back to that. These ages are crucial because the immune system, of course, develops in part prenatally, but the so-called adaptive immune system cannot develop until the child is out into the outside world and can start relating to possible pathogens and other foreign proteins that the immune system are supposed to respond to. So you can see that there is a certain value to using this concept. And having done that with the immune system, we wanted to also look at this in regard to other outcomes. Now, let me first show you here, this is Anneliese Blumberg's results on serum lipids. And on top here, we have the total cholesterol. This is HDL in the middle, and the lower panels are the LDL cholesterols. So, and here you have the various PFASs. It's very clear that when you look at age 9 years, there is actually an increase in total cholesterol that's related to the exposures. That is particularly for the girls. And you can already see that at age 5. But if you look at HDL, it's particularly the boys that show an increase. And with LDL, it's again the females that are apparently the most vulnerable. We actually don't see any significance with LDL in the males. So apparently there are some sex difference in regard to the vulnerability to the PFASs. We wanted to dig further into this, and first of all, we're now looking at particular subfractions, not just HDL and LDL. We're now looking at the various lipoprotein subspecies of the cholesterol, because it's known that ApoC3 is one that predicts particular adverse outcomes in regard to cardiovascular function. And it's also been seen, at least in adults so far, that it is susceptible to adverse effects from the PFAS. So we're looking at this right now. Unfortunately, I don't have any results yet. But we want to see this in a greater picture. And as you know, the liver is a key organ in regard to lipid metabolism and both adiponectin and leptin and also resistin are part of a family that at least in part are being secreted by the lipid tissues. I think resistin in humans are also secreted by the liver. But anyway, these are hormonal signal molecules that determine our likelihood of getting obese, our risk of type 2 diabetes, and other adverse effects. So these are important signal molecules, and they can be easily measured in serum, which is what we did. So first of all, let's look at the adipokines at birth. And this is calculations that Arya Shi has done, also as a postdoc at Harvard School of Public Health. And you can see that this is the three adipokines that we measured. You can see that when you look at them in cord blood and link them to PFAS concentrations in the cord blood, there's nothing there in particular. But if you then start looking at adipokines at age 9 here on the right-hand side of the slide, you can see suddenly PFOA turns out to show there's a decrease in leptin at age 9 in the cross-sectional design. But we also have earlier blood samples. So let's look at those and see how they relate to the adipokines at age 9. Here we have age 5 here in the very middle, 18 months. And then we also relate them to PFASs in the cord blood. And we already agreed that the cord blood had no influence on the adipokines in the very same cord blood, but as you can see here, they also don't appear to affect the levels at age 9. But then when you start looking at what's going on here, you can see leptin, it already appears at age 5 that PFOA clearly has an influence and decreases it. It doesn't really show up at age 18 months, but PFNA does. And then if you instead look at resistin here on the very top, you can see that there's something more going on at age 18 months. Now, we were very interested in figuring out if resistin, now that it seems to be affected by the PFAS exposure at age 18 months, what about before that time in infancy? So what we did was to look again at the age 9 adipokines, and here you have the lack of association with PFAS at birth, and here are the results for age 18 months that I just showed you. And now I'll show you the results for the estimated serum concentrations of the PFASs in infancy. And here they are. And what you see is that for leptin, nothing really shows up, and the same for adiponectin. But for resistin, where we did see an association here, a lowering with PFNA and PFDA, and perhaps also PFHXS, you can see that there's a lot going on earlier in childhood. And that indicates to me that we need to look at this in a greater detail in regard to the age and exposure. That is, the blood samples that we use or the estimations that we generate so that we can find the particular ages or developmental stages where the body is the most sensitive to effects on metabolic patterns, or it could be immune system functions, or it could be bone generation. So from this exercise, we conclude that PFAS exposures change substantially during childhood, and that the serum PFAS concentrations are not stable, and we need to look closer at programming toxicity, changes in the programming of body functions that may have happened prenatally, but also in particular, especially for PFAS, is because the early postnatal exposures are so large in association with breastfeeding that we really need to look at the early postnatal associations. So we think that cross-sectional studies underestimate what's really going on, and we think a lot of the literature may not have assessed PFAS exposures at the right time, and therefore need to be done over again with exposure assessments for early postnatal life. So we suggest that PFAS exposures be measured repeatedly in children, or if you want, you can use the algorithm that we generated, relying on the duration of breastfeeding. This is important because, as you know very well, the exposure limits for PFAS have decreased over time. They used to be more than 100 ppt for PFOS and PFOA, and EPA lowered their recommended guidance level to 70. But last year, the European Food Safety Authority concluded that the exposure limit should be lowered substantially, and it now corresponds to about 2 ppt in drinking water. That decision was made on the basis of developmental toxicity of these compounds. And so I think that any future adjustments to the current risk estimates, they need to be based on information on early life exposures to the PFASs. So overall, what we've seen in the FLUOROS and also elsewhere is that the PFASs are in fact toxic at current, what we call background exposures, and that we need to look at prenatal and early postnatal development as vulnerable time windows, and that we need to figure out more carefully what the vulnerable time window may be so that we can relate the outcomes to exposures during that time. And my final conclusion is that future risk assessment must be aimed at protecting against toxicity to the early life programming of organ functions. I want to thank you for your attention.
So a big thanks, Philippe, for this fascinating and insightful talk, and very influential, of course, in lowering detection limits. This is back in Providence. We had a minor gap in communication with Brussels. Might have to do with the fact that some guys in red socks beat some guys in striped, and the locals are very happy about it. But without further ado, back to Brussels, hoping that the rest of the session will be without any technical glitches. Thank you.
Well, thank you. Thank you also, Philippe, for these nice insights. I want to finish my talk, and I just want to say that all the information on HBM4U can be found at the website. So you have a description of all our activities. Maybe also I want to mention that we have a lot of communication products also for the general public. We have videos, we have fact sheets, we have all kinds of material. So we are building this HBM network, we are communicating, and we are trying to bridge the science policy interface. And our main main ambition is to support the Green Deal, because you all know Europe has a lot of ambitions with respect to chemicals legislation, and we hope to be able to support this ambition with science, and our human biomonitoring studies hopefully can be a new baseline for exposure to environmental chemicals, baseline for looking at the efficiency of the future regulations. Wienke Beer is a toxicologist and risk assessor at the National Institute for Public Health and Environment in the Netherlands, RIVM. She is she's the Netherlands, as you may know, leads the development of a proposal under the EU legislation REACH for the restriction of the use of PFAS. And Wienke, she's also in the Netherlands, committed to the evaluation of health hazards and risks of PFAS at the national levels, and also developing new tools for risk assessment dealing with PFAS. And I think your talk will deal with that. Please, Wienke,
yes, go ahead. Thank you very much, Greet. Hello, everyone. Today I will present some of the history regarding PFAS pollution in the Netherlands that has led to development of a framework to assess the risk to mixture exposure of PFAS, and how we further develop this within the HBM for EU project. So in 2015, a journalist of the Dutch media platform Follow the Money linked PFOA pollution in the US to historical use of PFOA at the fluoropolymer production plant Chemour in Dordrecht, the Netherlands. This article led to concerns in politics and subsequently led to questions addressed to the State Secretary of Infrastructure and Water Management, after which governmental advisory bodies, among which the RIVM, started researching the case. At first, attention went to PFOA. The factory emitted wastewater and air between 1970 and 2012. And a retrospective risk assessment was performed to assess the risk to possible health effects for people living in the neighborhood of the factory. Thereafter, a human biomonitoring study was performed to measure current PFOA concentrations in blood of residents, which were also used to confirm retrospective model calculations. And then GenX came into scope. The persistent bioaccumulative and toxic properties of this PFOA substitute were investigated, as well as current exposures to the GenX substance via emitted air and drinking water, and for the people working at the factory. The concern for carcinogenicity and accumulation of GenX in humans was further addressed in a REACH substance evaluation process as well. And then the scope of the risk assessments extended to combined exposure to PFOA and GenX. Risk assessments were performed for exposure to GenX and PFOA in vegetable garden crops and soil and irrigation water. But it was difficult to provide an estimate of the cumulative risk. So that's why in 2018 we received a request by the municipality of Dordrecht to investigate whether it was possible to express the harmfulness of PFAS in relation to PFOA, with the aim to develop a risk assessment framework for PFAS contamination in the Netherlands, and to provide estimates of cumulative risk to PFAS in different environmental compartments. So we looked into the possibility to develop the relative potency factor approach for PFAS. So what is the relative potency factor approach? It is a mixture risk assessment approach based on the principle of dose addition. Mixture components are assumed to behave like dilution of one another in terms of toxicity, and in particular to a certain health effect of concern. And this toxicity is expressed as potency factor relative to an index compound. And I will show how to use this in practice with an example later on. For the RPF approach, the group of chemicals and the toxicity database need to fulfill certain requirements. Firstly, the mixture components should show similar toxicity. Secondly, the mixture components should show parallel dose-response curves on a log scale. And thirdly, the mixture components should not interact. So with regard to similar toxicity, ideally information on the mode of action of the substances is available. For PFOA, a national TDI was derived in 2016 when exposure to people living in the vicinity of the factory was evaluated. And this TDI was based on liver hypertrophy in male rats. So this was also our starting point at that time for developing a database for other PFAS. For liver effects, PPAR alpha is a suspected mode of action, but also other modes of action are suggested to play a role in liver toxicity, such as CAR-PXR, PPAR gamma, or cytotoxicity. So the underlying mechanism related to PFAS-associated liver toxicity still needs to be further unraveled. From a practical perspective, EFSA was the first to introduce the concept of RPFs without the prerequisite of grouping chemicals based on a common mode of action, but rather based on the same target organ because information on mode of action is often lacking. And based on this argument, we compiled a database of liver endpoints of hypertrophy, absolute and relative liver weight of the 16 PFAS you may see listed here on the right. Using data with the same species, sex and exposure route and comparable exposure duration. Another important prerequisite is to check for parallel dose-response curves to ensure a constant dose factor between the curves at any effect level. So in that case, the RPFs will not depend on the effect size. When parallel curves are not ensured, the RPF are only valid for the doses which are the same as doses used for deriving the RPFs. Thirdly, we assume that no interactions between PFAS take place in vivo, so no antagonism or synergism. In that case, dose addition gives an accurate prediction of the cumulative effects if those relationships can be described by parallel curves. The dose addition concept has previously been confirmed for binary mixtures of PFOA and PFAS studied in several in vitro cell models, as well as preliminary research illustrates that in vivo co-exposure to Genix, Nephium byproduct 2 and PFOS results in a decreased neonatal survival in rat pups according to the concept of dose addition. And also a recent study by Marquez et al. Note that in vivo a PFAS mixture of PFOA, PFOS and PFHXS had very distinct effects when compared to single compound treatments, suggesting cumulative effects. So dose response analysis was applied to derive RPFs for PFAS based on hypertrophy, absolute and relative liver weight increase. We selected the RPFs for liver weight relative to body weight because that resulted in the highest number of RPFs. And in addition, the RPFs of 7 other PFAS were estimated based on read across. This resulted in the relative potencies of 22 PFAS compared to the potency of index compound PFOA. And this framework can be used to estimate the cumulative risk resulting from external oral direct exposure, such as via drinking water. So in short, PFAS concentrations in drinking water are multiplied with their respective RPFs to obtain PFOA equivalents, which can then be summed and then compared to a drinking water limit for PFOA. But there are several limitations for this set of RPFs, mostly due to the underlying database. Firstly, the RPFs are based on oral external exposure and should only be used to assess exposure via this route, because absorption via the inhalatory or dermal route differs. And secondly, RPF should only be used to assess direct exposure scenarios, so not involving absorption via plants or biomagnification, because such processes will interfere as they are not the same among PFAS. And lastly, the RPFs are based on liver effects in one database and require further validation also for other effects, such as immune and developmental effects, other sex, life stages, and species, especially when combined with a health-based guidance value not based on liver effects. With regard to the first point, we recently have looked into internal RPFs for human biomonitoring data to be able to interpret blood measurements and to perform a cumulative risk assessment. The reason for development of these specific RPFs is that PFAS showed differences in accumulation potential. So in other words, the kinetics determining the internal dose after external intake differ between PFAS. So consequently, RPFs based on intake doses will not be the same as RPFs based on blood concentrations. So interpretation of blood concentration data warrants other RPFs based on steady state blood concentrations. So therefore, we try to answer the question whether it was possible to express the harmfulness of PFAS in relation to PFOA based on steady state blood concentrations. And this is a conceptual overview of the methods applied to derive internal RPFs. At step 1, we started with the same database of liver effects for PFAS in male rats as for the external RPFs. And in step 2, we developed toxicokinetic models for 10 PFAS based on kinetic information in male rats. And we then verified these models for single and repeated dose serum measurements in the male rats whenever that information was available. And subsequently, we modeled the serum concentration time weight averages for the dose and exposure scenario in the toxicity studies that were part of the liver toxicity database. So that's the step at the right corner, upper corner. And lastly, we performed RPF analysis to derive internal RPFs in the male rat based on liver toxicity and serum concentrations. Again, we ensured parallel curves among the substances, and on the right you may see the RPFs and their corresponding confidence intervals. And interestingly, the RPFs for some shorter chain PFAS, such as PFH6A and Genix, are more potent than PFOA based on repeated dose serum concentrations in the male rat. And this illustrates that even if blood concentrations for these shorter chain substances are observed in human biomonitoring studies at much lower concentrations than those of PFOA, there is a concern that these substances contribute to a considerable degree to the cumulative risk. We performed a case study with PFAS biomonitoring data from the United States Enhanced Monitoring Program from 2017-2018. Exposure to 6 PFAS, you may see listed here on the screen, were converted to PFOA equivalents by combining serum concentrations for each of the 1,921 individuals, those with concentrations above the limit of detection, with internal RPFs. And the black line in the figure on the right represents the cumulative exposure as sum PEC in this population. We observed that PFOS contributed highest to the sum PEC, And this SUMPEC distribution should be compared to an internal health-based guidance value for PFOA itself, or on an internal health-based guidance value for the sum of PFAS that includes PFOA. Then another issue we worked on recently was further validation of external RPFs based on liver effects. So based on intake doses again, but then with another data set. That is because the external RPFs of our previous publication were based on a data set of toxicity studies available in the public literature, for which we noted that the influence of interlaboratory variation could not be excluded. So we therefore studied whether it was possible to derive external RPFs based on another data set that excluded interlaboratory variation. And for this, we used the 28-day studies for 7 PFAS congeners performed by the National Toxicology Program. So again, we performed RPF analysis for absolute and relative to body weight, liver weight increase in the male rat. And for this database, we excluded several dose groups that illustrated severe toxicity. So we excluded the 2 dose groups for PFNA and PFDA that showed more than 20% body weight decrease. And in the case of PFNA, also showed mortality. And on the left, the dose response curves for absolute liver weight, and on the right, for relative liver weight are shown. And here the correlation between the RPFs derived previously on the public data set and the data set of the NTP are illustrated. Those for absolute relative or absolute liver weight are indicated without an asterisk, and those for relative liver weight with an asterisk. Overall, the RPF confidence intervals based on relative liver weight for both data sets are in good correspondence, apart from the ones for PFBS and PFNA. For PFBS, the RPF based on the NTP dataset is higher, and for PFNA, somewhat lower, 7 instead of 14. For absolute liver weight, the RPF confidence intervals also overlap, apart from PFBS again and for PFHXS. But overall, there's good correspondence between the RPFs of both datasets. So that also excludes a large influence of interlaboratory variation. And lastly, the newly derived RPF for PFDA of 6 is within the RPF interpolation range we established previously. So in conclusion, mixtures matter, also in the case of PFAS. Co-occurrence in environmental media as well as in human blood requires to assess the risk of exposure to these chemicals as combined exposure. Parallel dose response curves are essential in derivation of RPFs to ensure a constant dose factor between the curves at any effect level. And RPFs based on intake doses are not the same as RPFs based on blood concentrations, because the kinetics determining the internal dose after external intake differ between PFAS. So interpretation of blood concentration data warrants internal RPFs. And these internal RPFs illustrate that shorter chain PFAS are of concern when detected in blood. We would very much like to increase the robustness of the RPFs, and we therefore need further validation of the relative toxicity of these substances based on other data sets as well. And I would like to end with an outlook of what can be expected from our work within HBM4U before it ends. We will publish a case study for the HBM study population, for which you saw a presentation previously. And furthermore, we will look into the possibility to derive internal RPFs for immune effects based on human epidemiological studies, complemented by internal RPFs based on immune parameters observed in the NTP experimental studies. So with that, I would like to thank my colleagues at the RIVM who contributed to this work, and the people that work together with me in the HBM4EU consortium. I would be happy to take any questions, or please send me an email. Thank you very much.
Thank you. Are there questions from the floor here, from the table? Yes, Ron, please.
Yeah, I think, yes, what you said is, I think it would be very nice to develop these RPFs also for immune effects, because I think one of the major issues whether the same mode of action is behind the effects on the liver and the effects on the immune system, which seem to occur at much lower levels, exposure levels. So I think that would be an important issue. And I think one other thing that also needs to be done is to apply then these RPFs on the risk assessment, because now they're not applied. Now we assume the TWI is based on equal potency. So I think if you would apply them, the TWI would probably be very different. So I have a little bit of a problem to compare data from toxicity from TWI without RPFs and then apply the RPFs on the exposure assessment, which may not be okay. So I think this is still something to work on.
Yeah. May I add something to that? I think there's assumptions there in both cases, because in the EFSA opinion where equipotency is assumed, we assume equipotency for immune effects in humans. And then on the other hand, we have internal RPFs for liver effects in male rats, which do not show equipotency, but there we have interspecies differences, also another effect. So we really need to study that more, I think, before we can say, okay, there's differences in assumptions there. But I agree that ultimately we should be able to get rid of those assumptions, also assuming equipotency for human immune effects.
There is a question in the chat. Is there any AOP validated assay for PFAS and its alternative?
Oh yeah, I think I already saw that question
From
previously.
Okay.
From the morning, I think.
Yeah. I was actually wondering whether the person who posed that question could elaborate on it, because
Maybe we can take it up later, because there are some specific questions for you, Wieneke. When shorter chains are not measured in the blood or are measured in the urine, would they still matter?
Yes, I think so. Yeah. But there again, we're looking at a different exposure metric. So again, RPFs based on blood cannot be directly applied to urine as exposure metric, I would say. So more work to be done.
Yeah, I see another question as well.
Yeah.
Shall I?
Yeah, please.
The progress to excellent talk from Rainer Lohmann. And it's also important to have this progress towards internal response factors. Any explanation why the relative potency of the PFAS does not increase with chain length, as is seen in many other studies?
Well, if we look at external exposure, so intake doses, the potency increases with increasing chain length. Is that a question?
Yeah.
I'm sorry.
In most studies show more higher effect with increasing chain length, and yeah, maybe Rainer can explain better.
Oh, I'm sorry. Yeah.
My question was for the internal exposure, which is a great step forward. It looked like even the GNX was very high, and there was one long chain, but others were different. So do you have any idea why this picture completely shifts when you go to internal exposure?
Yeah, because the accumulation potential, especially, we have a lot of information of that for that in the rats. The accumulation potential between short and long chain congeners changes very much. So it's basically with a lower internal dose, those substances are still able to result in considerable toxicity. So therefore, the internal RPF is way higher than based on external exposure because they accumulate less than the long chain substances.
Thank you. Tony wants.
Oh, Tony, yes.
Great talk. I think, yeah, it'd be really good to try and do that within human effects. And you mentioned immune effects. And I'm just wondering what kind of populations you might be able to do that for, because obviously with the animal data, you have single substance exposures. And most of the humans already have a mixture of exposures if you're using serum levels. I mean, can you kind of identify different populations where one PFAS is more dominant than another in different ways for different populations?
Well, we're still in the middle of this process, but we have developed a methodology on a fictive data set where we are able to, if we have enough individual responses where unique mixture exposure is combined with one effect, then we are able to estimate the relative potency factors for the individual congeners back from the unique mixture exposures.
By different populations with different mixture balances, you
Yes.
mean? Yeah.
So that's what we aim to do, but yeah.
Yeah, the question here, what I can see is to try to apply relative potency factors on immunotoxicity would be very nice. Which other studies are needed for that?
Well, I think what we're doing now is really an attempt to have an idea of immunotoxicity of PFAS and RPS, but ideally we would have a uniform database of T-cell dependent antibody responses in laboratory animals or a human data set with antibody concentrations.
So that was the invitation for people to...
Yes, of course, we're all working towards alternative approaches. So it would be even better to have an in vitro model to estimate the effect. But yeah, we need to carefully balance there, I would say.
Thank you very much. I think we are in for a short break. Thank you, Wieneke. Also, thank you all the people who asked questions and contributed to the discussion. So we will take some coffee and tea, and we will reconvene at 4:45. So in about 20 minutes from now. Thank you. Welcome back. So we will take the opportunity to continue our program, and it's a great pleasure for me to introduce to you our colleague Thor. He's professor epidemiology, connected to the Faculty of Food Sciences and Nutrition at the University of Iceland. That's he. Also, why his name is so difficult to pronounce. Sorry for that. But Thor is also member of the EFSA Scientific Committee and is also member of the Committee of Food Standard Agency in the UK. And he, in HBM4EU, is leading a task on exposure health associations. And I think you will tell us more about that in a minute. So please, the floor is yours.
Yeah, so thank you very much. My name is Þórhallur Ingi Halldórsson, but outside of Iceland, I'm Thor. And I'm here to talk about exposure health effects in EU birth cohorts, but sort of briefly what I will do in terms of the structure of my presentation, I would like to start by giving a few points on perfluoroalkyl substances, sort of issues that we need to consider when we are interpreting observational findings in humans, particularly with birth cohorts. Then I will talk a little bit about birth cohort studies that have reported associations with birth weight and later postnatal growth and cardiometabolic outcomes, not necessarily because I think these are the most exciting findings, but they highlight some of the issues that we deal with when we are are assessing risk to PFAS and sort of reflections on causality. And then I will briefly talk about some of the immune outcomes, association with immune outcomes, both previous finding and some new results from birth cohort studies that are a part of HBM for EU. So when it comes to sort of perfluoroalkyl substances, they tick several boxes associated with reliable exposure assessment. And the nice thing about them when you work with them is, of course, you all know about this, they are thermodynamically stable, so you don't have to worry about losing them when you repeatedly thaw and freeze your samples. They are easy to quantify, at least nowadays. There were problems associated in the early days, but many of them have been overcome. And more importantly, they have long elimination half-life. And on the right-hand side here, you see some individual half-lives among subjects in the Runneby cohort and for different long-chain PFASs. And what you can see is that even though you get a mean of certain years, the individual variability in half-life seems to be, at least based on this study, quite large. But the important thing is that at least for a period of few months and up to years, the exposure stays relatively constant. But when you're looking at exposure health association over several years with one exposure estimate, then you may run into some problems, I think. And I mean, and the downside that we deal with, and it's not only for PFAS, it's with all biomarkers generally, and also in environmental epidemiology, that exposure is not constant over time. And on the lower right-hand side here, you see some time trend studies on PFAS in breast milk, pooled breast milk samples from Sweden. And if you notice that within a period of few years, there was an almost five-fold increase in the sum of PFAS in breast milk in Sweden, and that then started to sort of decline and went a little bit up again. And over time, the mixture is also changing. So exposure is not constant. And the other complicating factor is that it's difficult to tease out individual association for different PFAS. And more importantly, there are, I'm trying to change the slide here, and nothing happens, that there are factors that influence rate of uptake and or excretion, which may contribute to confounding. Now, it's quite easy to focus on the sort of limitations, and this is not specific to PFAS, this is specific to any epidemiological studies that you do, but it's important to understand which factors these are. And what we have sort of been gaining better understanding of is that fiber-rich foods may increase gastrointestinal excretions of PFAS. And to the left, you see a recent publication from the Haynes study, which is based on two 24-hour recalls, where they showed that across quintals of long-chain PFAS, there is about 10 to 12% reduction in PFAS among subjects cross-sectionally with high fiber intake compared to low. Now, we did a previous study in Denmark on pregnant women where we looked at different food groups, including red meat, saturated fat, and vegetables, and saw the same trends, more or less, that pregnant women with high vegetable intake had lower PFASs and pregnant women reporting high meat intake using food frequency questionnaire has substantially higher levels of PFAS cross-sectionally. And this has nothing to do with the fact that meat has higher concentrations of PFAS. This has to do with the diet. So if you have high meat type of diet, you tend to have low fibers and vice versa. And the difference there is up to 25%, which offers some room for indirect correlations, let's say that. Now, and during pregnancy, things get quite complicated. And the important thing here is that, well, if we focus first on the graph to the left, that immediately, sort of shortly after pregnancy occurs, the glomerular filtration rate is increased to up sort of on average up to about 50%. You have also substantial increase in cardiometabolic output, and later as pregnancy progresses, there are a substantial or up to 30% increase in blood volume expansion. And these physiological changes occur to support fetal growth. And therefore, it is theoretically possible that for women who have high birth weight infants, where there's rapid fetal growth, these factors play a bigger role than compared to where you have slower fetal growth. And this offers some room for confounding. Now, the sort of the positive side on the right-hand side, where you see a scatter plot from the Danish National Birth Cohort of PFOA samples on the x-axis, which are taken very early in pregnancy, prior to many of these changes reaching their full potential, and then in middle of pregnancy around week 25. And here you see very close correlation. So if you rank women based on the first sample, you will rank them relatively accurately based on the second samples. But there are important deviations. So it depends on which side of the coin you're looking at. If you know the physiological changes and you know that they are associated with fetal growth, you're worried. When you look at the scatter plot, I would be less worried. And this is often how it is in epidemiology. Things are complex. So let's continue with that in relation to studies that have published associations between PFAS in maternal serum or cord samples in relation to birth weight. And what I've done in this slide here, which is, I think, probably unreadable, or I at least can't see the screen here, is that I've taken a large table from the previous EFSA opinion on PFOS and PFOA and ordered the studies according to increased, so starting with the lowest PFOA concentration and ending with the highest PFOA concentrations among 15 studies that measured PFAS during pregnancy. And if you look at the column for PFOA, the regression coefficient, I've highlighted in bold some of the significant association. And in an ideal world where everything is causal and everything works, you would like to see stronger association in studies at the lower end where the concentrations are higher, and you would like to see, well, some kind of consistency. But the only consistency that I see is that, yes, many studies are reporting inverse association. If there was confounding, I would expect to see stronger association in the cord blood studies, but I can't really see it, but it might be there. If I would do a meta-analysis and take the average, I would get an average probably significant estimate. And if I would add the C8 study, the large study that didn't see anything on birth weight, I would conclude that there's nothing. But and this is the level of complexity, but I'm a lazy epidemiologist and I don't like meta-analysis, so this is enough for me. Now, if we focus on the Danish National Birth Cohort, they did a reanalysis of their samples where they added 2,000 something samples on top of their 1,400 samples that they initially published. And here on the left-hand side, you see the regression coefficient and decrease in birth weight across quartiles of PFOS and PFOA. And the thing that I want to point out here, that this is first trimester pregnancy samples drawn in week 4 to 12, 4 to 14 maybe maximum. And here you can see around 120 gram decrease in birth weight, which is strongly significant and modest effect size. But when they look at risk of low birth weight, meaning prevalence of children being born below 2.5 kilos, you have a non-significant, slightly elevated odds ratios of around 1.5 no dose response. The interesting aspect here is that the prevalence of low birth weight in this cohort is a little bit lower than in the general cohort, but that has something to do with selection, I think. Now, what does a 50 to 100 gram reduction in birth weight mean on its own? And this is something that we usually reflect about. I mean, there are epidemiological studies done with outside of environmental research, and when we look at lifestyle factors, including physical activity, dairy consumption, adherence to plant-based diet, we see similar variation in birth weight, sometimes associated with adversity. We see increase in risk of low birth weight or something similar, and sometimes not. And it's really difficult to evaluate. So if it was, sort of just lifestyle epidemiology, you wouldn't necessarily be very concerned. But within environmental epidemiology, we are, of course, naturally. Now, if you look at the strongest environmental factor that we know, or one of the strongest environmental factors that we know that determines birth weight, that's maternal smoking. And here you see from the Danish National Birth Cohort, the full cohort, the 47,000 something women that did not smoke during pregnancy, and the 7,600 women that actually reported to smoke daily during pregnancy, because the cohort is recruited subjects in a period where it was more socially acceptable to smoke during pregnancy, in Denmark at least. And here you see a shift in the birth weight distribution, which is quite clear, and you see also a shift in the residual part of the birth weight distribution where the low birth weight infants are. and there's a relative risk of about 2.3, and there is a 250-gram mean reduction in birth weight. And taking into consideration that the effects for PFOA was around half of that, if we do a power calculation, you would probably need around 2,400 mother-child pair per quartile, or 10,000 in total, to have sufficient power to detect a relative risk of 1.5. And usually in observational environmental epidemiological studies, we don't have it. And this is the missing link. If there is confounding, there could equally be confounding in a way that you shift more children into the low birth weight category. But this is the problem that we are faced in environmental epidemiology, that we cannot really always study these hard clinical endpoints. Now, that was something that I was supposed to do in the HBM4EU project, and I'm still working on that. When we move to postnatal growth and cardiometabolic outcomes, there are quite a lot of studies that have been published. And what I want to focus on here, well, I'll start with my own study that I published some years ago on maternal serum concentrations of PFOA measured during pregnancy in a birth cohort study from Aarhus, which was conducted in 1808 and 1809, where people were being advised to leave sort of saturated fat and shift to refined carbohydrates, but these were predominantly lean mothers. There was only about 8% of them that were overweight and obese. But 20 years later, their children, the prevalence of overweight obesity among them was about 20%, because that was the sort of the obesity epidemic was taking place there. And what we found in that study was a very strong correlation between maternal serum concentrations of PFOA and propensity for being overweight and obese among the female subjects 20 years later. And we saw also their metabolic profile was adverse, and this was not as pronounced in the males. And this was, we found at the time, it was quite spectacular, and we're very excited about it. It was one animal study that had shown something similar, but later there came other studies not showing it. And what we've been doing in HBM4EU, my Norwegian colleagues have done a large study where they follow the children up to 8 years of age, where they see absolutely no indication of this type of an association. There have been several studies also from the INMA cohort in Spain, and within HBM4EU, they have been following the children up until the age of 11, and there is very inconsistent or unclear association also observed there. There have been large, very nice, well-conducted studies from the Helix project on lipids and cardiometabolic risk factor in the children, and if you ask me, the associations reported there are sort of inconsistent, I would say. So what is the issue then with epidemiological studies looking at 1 point estimate during pregnancy in relation to cardiometabolic risk factors over body weight many years later? Now, the problem is, of course, that exposure is not constant. And the problem is also, I think, the more I think about it, and I'm not criticizing these studies, we have to do these studies and we have to be better in doing them. And I think the good thing about what I've been reviewing here is that for studies where there is inconsistency, people are quick to spot it out, and sort of and lack of consistency means is a take-home message that is quite clear. But what I've been doing in maternal epidemiology is looking at dietary factors. We see that there is a very strong sort of, let's say, shared familial environment when it comes to diet. And in this study that we published in PLOS Medicine 2 years ago, we could see very strong correlation between the type of diet that the mother reported when she was pregnant and how the teenagers at age 14 years were eating. So if the mother was eating a lot of fruits and vegetables, the teenager was doing that themselves. They deviated a little bit with maybe sweets and so on, but there was a very strong shared environmental factor. And this creates room for confounding. I'm not saying that all studies are confounded, but this can create these sort of inconsistency that we see. So maybe stratifications or some adjustments would be helpful. Yeah. Now, when it comes to immune toxicity, you heard from Philip this morning. I mean, that's quite clear that maybe one of the most consistent findings, depending on how you evaluate the evidence from human epidemiological studies, are on inverse association between serum PFAS concentrations in children or in pregnant women and reduced antibody response in the children, either after infections or cross-sectionally or prospectively. And that's quite consistent, even though not all studies have confirmed this. And this is also backed by animal models. I think this is one of the few outcomes that you see both in humans and animals. But if you look at the animal models in detail, you see various, well, the effect where the concentrations where this effect occurs is slightly varying. Now, I'm trying to, and the problem sort of in terms of, well, we always want more information, and for many people, the changes in antibody concentrations are sufficient to flag adversity, and I think that's correct. But ideally, you would like to know what this risk basically translates into. Does increase in antibody concentration translate into higher propensity for infections? And one of the early studies from the Danish National Birth Cohort that you see on the left side there looked at maternal concentrations measured during pregnancy to PFOS and PFOA, and risk of hospitalizations due to infections in the offspring up to about age of 6 years of age, where they found no indications of increased risk of propensity at all. But if you look at the publication, based on later publications, if you look at it slowly, sort of in detail, they lumped all types of infections together, and the way they analyze the data may perhaps, not necessarily, but there's possibility that it may have contributed to the null findings in a way. There was a later well-conducted study from the Odense birth cohort that reported association between symptoms of infections in the children from age 1 to 4 years of age. And this was done by, instead of relying on self-reports, that the mothers, they texted every week whether the child had symptoms of infections or not. So it's done in real time, which minimizes the risk of bias. And the most pronounced association that they saw there were for fever, if I remember correctly. So there are were conflicting reports on infections, or have been until recently. And so what we have been doing, partly Tina Kold-Jensen from the University of Southern Denmark, and we have been doing, is to look at some of these cohort studies in relation to propensity for infections in children, and see her group. Now I'm trying to change the slides and nothing happens. Yeah. And her group recently published this paper here, where they did, similar to the Danish National Birth Cohort, they looked at propensity for hospitalization due to infections using registry-based data, where they both looked at all types of infections, but they also looked at different subtypes of infections. And just to give you a short detail, I mean, what the prevalence for the upper and lower respiratory tract infection was, of course, higher. And if we compare with the recent EFSA opinion of a critical value for the sum of 4 PFAS of 6.9, if I remember correctly, the exposure level in this cohort is slightly higher. And what they find some modest but quite convincing positive association with increased propensity of hospitalization due to infections for PFOS and PFOA, which is more pronounced for lower respiratory tract infections. But for some infections like gastrointestinal infections and the group called other, it's quite inconsistent. And they are analyzing the data further, looking at both maternal and the offspring's own PFAS concentrations related to antibody concentrations. And as far as I understand, these ongoing analyses are very well in line with their previous findings. Let's just say that. Now, I've been doing some work on the cohort that I have access to in Denmark, this cohort that I published on overweight and obesity from 88 to 89 in Aarhus. There are around 900 women where we quantified serum samples in third trimester. And while the children, the registry, the pharmacological registry was not up and running until 1995. So we got information on use of antibiotics in these children when they were age of 6 years. It's a little bit of a limitation that it's so late, but we will look at hospital infections as well in the early period. And what we looked at in these preliminary analyses are the association between mother's concentration during pregnancy and offspring use of antibiotics from the age of 6 to around 13 years of age. And if we just do a crude comparison between the concentrations of mothers whose offspring had used antibiotics less than 3 times or 2 times or less between the age of 6 to 13, and we take the top 90th percentile of antibiotic users, that those children have used antibiotics 3 times or more during this period, you can see there's a clear, significant difference. Well, the p-values are not there, but there are clear differences in PFAS concentrations between these two groups, which are most pronounced for PFOA, which maybe is understandable because the placental transfer and lactational transfer is greater for the carboxylates than the sulfonides. And if we just look at it in a static way, both for PFOS, PFOA, or the sum of 4 PFAS in terms of odds ratio, which is not maybe the most relevant statistic to do, this is just preliminary, we could see quite clear dose response in all cases. Now, the strength and limitation of these type of studies that have been published or are on the way to be published is that these registry-based studies on infections or use of antibiotics are sort of have their strength because there is no loss to follow-up. But the limitations are that the reason for hospitalization during the first years of life depend on many other factors than just the severity of the infection. And I remember when I had my kids in Denmark with very easy access to a hospital, you would usually run in there for a check if you were worried. The same with the use of antibiotics. We only have it from age 6, but this is the case with many epidemiological studies that you use the data in the best way that you have, and the designs are not always optimal. But I think the consistency of the finding, if we just take the Odense cohort on maternal report of infections and then the risk of hospitalization is quite consistent. So in conclusions, despite their persistent nature and stability, serum PFAS concentrations are affected by variability in uptake and excretion that needs to be considered when interpreting epidemiological findings. But this is not unique for PFAS, and it's easy to drown yourself in limitations, but this is something that you have to think about. But if you take serum 25-hydroxy-D, you have problems there as well, or whatever biomarker you choose. I think the jury may still be out there when it comes to birth weight, but I think mechanistic studies like we heard this morning in the morning session, if we were there on the placenta, and something similar is needed, not just more studies to provide clarity. And I think recent findings on infection provide some support for the new TWI set by EFSA, which is derived on serum antibody concentrations. And if you look at it in a broader perspective, I think adverse effect on the immune system may result in indirect spillover in terms of other associations and other health outcomes. And I remember I had a PhD student 10 years ago who were looking at an historical birth cohort in Iceland around the time when the Spanish flu hit, and you can see a really strong hit on birth weight. Well, Spanish flu was quite strong, but there are derived consequences of infections that can have an effect. Thank you.
Will you take the questions?
Yeah, but
I can see them.
me, I know.
Is there a question here from the floor here in Brussels? I can give the word then to the US people.
So thank you for that talk. We had a question regarding that discussion of power that you mentioned. So someone asked concerning Wilmington, North Carolina, which is an area with some drinking water contamination. This area can provide statistical power with about 300,000 exposed residents. So have any EU or any other global epidemiologists considered researching this location?
No, I was not aware of that you had so many exposed residents there. But no, I mean, I think what the opportunities that we have with these unfortunate, let's say, groundwater contamination in various places offers the possibility to look at rare disease outcomes to a greater extent than we have done in these European birth cohorts with relatively modest exposure contrast. So I think the possibility to do more things are certainly there. And there was also a question about immune suppression and type 1 diabetes and sleep disorders and so on. Well, I mean, for type 1 diabetes, you would have to do a nested case control study, and in theory that is possible. You have to wait quite a long time. But I know, for example, in the Danish and the Norwegian mother-child birth cohort studies, the possibility for that type of nested case control studies exist, and I assume the same exists in other sort of large databases. Yes. And of course, with better evidence for immune suppression, I think it might be easier to get access to samples there.
Maybe I can read it.
Yes.
What sorts of confounders exist for these health studies? Is PFAS exposure associated with socioeconomic status or other chemical exposures? I'm curious what has been considered.
I mean, in the early days, when you looked at PFAS concentrations across socioeconomic status and that sort of variables, you would get the impression that the exposure was more or less random. Nothing is completely random when it comes to exposure, but there were no immediate red flags. Our understanding of the variability in uptake and excretion has sort of pinpointed some possible routes for confounding. But I think it's important to consider, I mean, we have, for example, well-defined mechanism for confounding for birth weight. The one exists also for lipids to some extent, but full confounding it does occur, but more often in epidemiology. If you just take smoking and cardiovascular disease risk or cancer, I mean, there are partial confounding happening every time for most epidemiological studies. So even a possibility for confounding doesn't mean confounding. Risk of bias doesn't mean bias. It's a risk of bias. And I think teasing it out, and that's why I was choosing the birth weight example. I mean, yes, there might be confounding, but whether it's full confounding, partial confounding, or no confounding, it's sometimes really difficult. But I think we need to reflect on these confounding. The existence of a mechanism for confounding is not the same as confounding.
Maybe I can ask, so you talked about confounding factors, and on top of it, we have exposure misclassification. So we should add both, or how should we look at it?
On the other hand, I mean, the PFAS are really stable. They reflect long-term exposure. There's a lot of, I mean, I feel more comfortable working with PFAS than pesticides in a way. So, I mean, it's easy to, but there are, of course, misclassifications but I think for some outcomes, there is a consistent pattern. For some of them, we should expect that there is partial confounding. But like I say, with the long-term outcome, sometimes you just convinced that what your initial findings were not correct. And that happens 40% of the time in all my studies, I think.
The changes happen postnatally.
Yeah.
You have a question from the US.
Okay.
Oh, yes, I added a question as well. You can feel free to go.
Please go ahead, because I can't see the question. So.
Hi, so I'm clarifying the statistical power question. I actually am from North Carolina, but I also know that there are regions in Europe that have get close to statistical power in the Netherlands and then in Italy. And so I guess the greater question I have is, from a contaminated communities perspective, we hear a lot that it's hard to get epidemiological research because of the lack of statistical power and funding. And so I guess I'm just putting this out here is, if we know the locations, can we pull together global resources and really start studying the already exposed humans in these regions of the world to kind of further us along in the progress of what exactly is going on?
Yeah, I think that would be fantastic, because I would not like to see the next year continuing to fill the journals with papers on more or less the same. We need to use these, I wouldn't say opportunities, but these sort of unfortunate events to actually study them. I think I fully agree with you there.
Okay. Thank you.
Susan Richardson, University of South Carolina. A question, and I've been mostly in the disinfection byproduct world in drinking water, and we've had similar things in the past with not enough statistical power to tease out these effects. And I'm wondering what happened in my world was that they pooled, Christina Villanueva from IS Global and Manolis Kojovinas pooled a lot of raw data from many locations around the world, many cities, and they were able to get statistical power where they saw a dose response, a clear dose response in humans for disinfection byproducts in bladder cancer. And just wondering if you could possibly pool the data from these different studies, because realizing the Faroe Islands is probably a really small population to be able to tease out much of anything. So can that data be pooled?
Yes, I think that's the case. We've had some, I wouldn't say problems with data protection issues, but the environment has been changing, which has sort of led to us using more of our time figuring out how to do this. That would be my short answer.
Okay, thank you. Maybe we have to continue with the next talk. This will be given by Christina Jacobson, but she's not here. She will connect remotely. Christina, you are there, I hope. So Christina Jacobson is professor at the School of Public Health at the University of Gothenburg. She's a physician, an epidemiologist, and has a lifelong working experience on occupational and environmental medicine, studying diverse topics, including health effects from asbestos, also environmental air pollution. More recently, also polybrominated compounds, and now she's also working on polyfluorinated compounds. And she will tell us more about the epidemiological work on the Ronneby cohort in Sweden, from Sweden. So Christina, nice seeing you. Please, the floor is yours.
Thank you very much for inviting me to talk about our Ronneby PFAS research program. I would like to talk about the background, a bit of our resources from our research and results so far in brief. Yeah. It all started some 8 years ago in Ronneby, a small municipality in the southern part of Sweden, where it quite accidentally was found that the aquifer and the groundwater was heavily polluted with PFAS from a military airfield. And it happened to be a municipal waterworks in the middle of that polluted area. So they had 2 waterworks in this municipality. 1/3 of the households were supplied from the highly contaminated waterwork. And as you can see, there is a stark difference between the outgoing drinking water levels of PFAS in the contaminated waterworks, about 10,000 nanograms per liter, compared to much, much lower levels in the other waterworks. So, of course, this was a tragedy for all involved, but it also gave us an almost perfect natural experiment to research on PFAS and human health. We started with offering everyone in the municipality to have their serum sample analyzed for PFAS. We had open blood samplings, and about 3,500 persons came. And most of them also agreed to have their blood samples in a biobank. We also had a reference group from a nearby uncontaminated municipality. And as you can see, in this biobank, we have samples from toddlers up to old people, and we have serum levels from background levels up to very high. So what's happening now? So to put this into an international perspective, this is a hotspot population. It can be compared to other hotspot populations, for instance, the C8 population, where you have high levels of PFOA in the highest contaminated district, while we here have exposure that is dominated by PFOS and PFH excess. And the PFOA levels are much lower. Another hotspot population is the Veneto population in Italy. And as you can see, this is also more PFOA than PFOS and PFH excess. So we actually have two distinct populations when it comes to the mixture. And also we have to keep in mind, let's see what's happened, what will happen, that most other studies are performed in the general population with background exposures, looking at exposure contrasts at the very left-hand end of exposure. Here I made circles from the uncontaminated neighboring municipality, which is about background Sweden and background in many European countries. So we have to keep in mind when we compare between different studies that the mixture may differ and the exposure range may differ very much. So what kind of resources for research do we have? We have all persons ever registered as living in the municipality during the time where we have good reasons to believe that there was ongoing exposure. We know their residence and also their drinking water source by calendar year. For most of them, we also have some notifications of their workplace. And this enables us for accrued exposure modeling, ever or never residing with contaminated water at home, residing in an early time period or in a late period, or many years or only a few years. So this seems so how can we justify this crude modeling where there is no earlier water PFAS data and no data on the use of firefighting foams in the military airfield? Well, we know things about the hydrogeology, we know things about the transport, we know about the waterworks wells and production info, and we do know serum levels in our cross-sectional study about half a year after end of external exposure, taking half-lives into account. And as you can see, there is a marked difference between those living outside the municipality at the lower end of this table and those living in the highly contaminated area up to the time where we sampled them. Also those living in the municipality, but they have never been living in the contaminated area, had higher serum levels than those outside. Of course, you don't only drink water at home, you drink water elsewhere too, so it's quite reasonable to find. But it's also important to understand that investigations within the municipality covers an exposure range, which is not for everyone consistent with background exposure. We also have the possibility to look at population and elimination after end of exposure. In the Ronneby population, starting about half a year after end of external exposure, but also another small population where we were able to have serum samples almost immediately after end of exposure. And we clearly see on the one hand that there is a difference in half-life between compounds, shorter half-life with the shorter cold chains, but also there seems to be a pattern of more rapid elimination in an early phase compared to later. And this, to me, indicates at least a two-compartment elimination. And as Thor showed us, a large individual variation in half-life. Let's see what. Ranging from a bit more than 2 years to up to more than 10 years, for instance, observed for PFHSS. So this individual half-life variation is clearly a dominating source till the observation of different serum levels, even if there is a continuous exposure. We do know that there is a shorter half-life for women in reproductive ages, but also it's shorter at young age. It's shorter if you have a good kidney function, and it's shorter if you have indications of gut inflammation. Of course, we want to understand more about it, so we are preparing elimination studies to try to manipulate the elimination by blocking renal excretion, by blocking gastrointestinal reuptake, to look at if there are differences between PFAS compounds. And there is also in planning an extended trial to see if such experiments during a long-term medication actually will change the serum level. So what about outcomes so far? The main Ronneby registered cohort, as I said, enables us to a comparison within the community. We have been looking at thyroid diseases, inflammatory bowel disease, at benign gynecological diseases, on cancers. We are looking at diabetes, hypertension, and fractures. We extended the cohort to include all the county for birth outcomes and pregnancy complications, meaning that we can compare within Ronneby and outside Ronneby. And of course, we want to extend our main registry cohort to incorporation of all county persons. So, we did not find any increase of thyroid disease. Neither looking at diagnosis from national registries and not in our biobank samples when it came to hormone alterations. We did not find any increase of inflammatory bowel disease, neither for Crohn's, colitis, or other unspecified IBD. And also markers of gut inflammation and gut integrity did not indicate increased gastrointestinal inflammation. We did not see an increase of endometriosis, probably not for uterine fibroids, but we did observe an increased risk for polycystic ovarian syndrome. In the highest exposure category, it was about twofold, comparing those with those never residing in the contaminated water district. For pregnancy complications, we could look and compare within the municipality, but also with the county. And we found nothing for gestational diabetes and nothing for gestational hypertension or preeclampsia. We have been looking at cancers, and now it becomes, I wouldn't say complicated, but you have to think what you're doing. We have investigated 35 sites for males and for females. We have made external comparisons with other parts of Blekinge as reference outside the municipality. And we have made internal comparisons looking at never residing in the water district or ever, or residing for a long period or short period, a late period or an early period. So it is a lot of comparisons. Here in this slide, we summarized findings where there seem to be a consistent increase or decrease in these different internal comparisons. In this way, we looked at kidney, bladder, brain, bone, thyroid, testicular, and prostate cancer with some consistent patterns. Also, for prostate cancer, it was clearly a decreased risk, and similar for breast cancer in women. I think it's important to take this kind of findings into consideration of what is found elsewhere. Where do we have consistent findings? And I would say kidney cancer has been reported elsewhere. It might lead me to think that there might be a causal relationship. For testicular cancer, yes, there are also findings. Thyroid cancer, so. For the other sites, I would say that this is interesting observations, and we need more evidence from other investigations in order to actually understand more about causality. So what about findings in the biobank samples? Yes, we found an association, a positive association between increased PFAS levels and cholesterol and low density lipoproteins. We also had positive associations for some microRNA and for DNA methylation. There is more to work on with these samples. We also have data from the child health care centers, where almost all Swedish kids go for health checkups from birth up to they start school. So we retrieved child charts from the healthcare centers up to 2009. That is 4 years before the contamination was found, which means that whatever data there is, it is unbiased by knowledge about contamination. We are looking at breastfeeding initiation and duration. We are looking at childhood growth and on language development as a good sign of the neurocognitive development. So it's going fast. No, I'm trying to. Okay. We have been looking at breastfeeding initiation and duration. What was found, and I'm sorry I can't show you the picture, is that there was an increased risk of shorter duration of breastfeeding in women with high exposure. In this case, as observed during a time window of 5 years before the birth of the child. And also, there were more women who did not initiate breastfeeding in the high exposure group. So maybe that is something to look at in other studies. We have a mother-child cohort, about some 300 mother-child pairs that are followed for transfer of PFAS between mother and child during pregnancy and lactation, more on breastfeeding, and of course we will follow the kids over time. And then what about PFAS and COVID-19? Well, a very crude ecological comparison does not indicate a very severe extra risk in the municipality, just comparing a number of reported cases by municipality and remembering that you have the high exposure only in this municipality. But of course, this kind of very crude comparison is not what you need to do. So what will follow is, of course, a proper registry study looking at all Blekinge and have good outcome data on COVID infection, on COVID disease severity, etc., etc. So this is upcoming. And we also have a vaccination study because we managed to recruit persons before getting vaccinated, and they are resampled after full vaccination. We will follow up with the new sampling 6 months later and look at both antibody and cellular responses. So with that, I would just like to remind you of the resources that we have, also resources that we would like to share with others who are interested in collaborations. And thank you for your attention. Of course, many persons have been involved in this work. Some of them are mentioned here. So now I'm open to questions.
Thank you, Christina. Is there a question from one of the people here in the audience? Not directly, but maybe I can give the word to Jedi.
Yep, so there are some questions on our end. So the first is, was there any analogous study looking at other paths of exposure for the observed levels in the residents of the county in areas believed to be uncontaminated?
I would say that there is a possibility to use the national registries of disease and identification of personal number and spatial information. So there is a possibility to do a lot of comparisons.
Thank you. And there's another question as well on that you mentioned other studies finding associations with kidney and testicular cancer, but not the other cancers shown. So were the results for associations for PFOA while your study in Ranabee is for exposure to multiple PFAS, were those results for other cancers shown?
I mean, if you look at findings from the C8 study, which also is a hotspot, reporting kidney cancer, testicular cancer, and we find it also in this PFOS and PFH excess highly exposed cohort. When it comes to studies of these cancers in background populations, it is, of course, more of a mixture, but at a totally other end of exposure levels. So you have, I mean, should we compare? Yes, we should. Can we compare? Not without hesitation.
Yeah, thank you for that answer as well. I had a question as well on the inter-individual variations that you mentioned in the half-lives. So I was wondering like which kind of lifestyle or behaviors you may hypothesize to be affecting that variation.
Sorry, could you repeat your question?
Yeah, I was curious about.
And
so you mentioned some factors that could influence the inter-individual variation in half-lives. So I was curious about related to that, are there lifestyle or behaviors that could also be explaining those differences?
If you add the information on diet and which might influence the gastrointestinal reuptake. On the one hand, you might find things that are influential, but it might also differ between the body burden, how much it matters or not. So clearly, we need to understand more. For instance, we need to understand more about the microbiome, which might be a very important factor within the gut.
Okay, thank you. Are there more questions in Providence, or did we get all the questions from there? It was a little bit difficult to understand here, I must say, but
Yeah, I
thank you,
had
Chris.
another
please.
question from
Here's a
Reiner.
question from Providence.
Yeah.
So thank you for the talk. I was interested in, you had a slide about some studies involving interventions, and I just wanted to kind of maybe get a little bit more information about some of the interventions you might be looking at with regard to renal secretion, because depending on maybe potentially like how you're affecting, are you looking to, I guess, prevent renal uptake, or are you looking to inhibit renal reabsorption? Can you tell me a little bit more about that hypothesis? I find it very interesting.
Well, what we are planning to do is to try to block the renal ionic transporter by probenecid, for example, and see what happens.
Probenecid is usually is taken up into kidneys. So would the net result for that excretion, like for it to stay in the system, or with probenecid you would be usually that would be where it would be inhibiting, versus tubular reabsorption?
I mean, you have both processes, excretion and uptake. So we essentially want to see what happens when you block transporters. Does it matter or not? There are some experimental data that things might change. And for gastrointestinal reabsorption or blocking of that, there are observations with cholestyramine, which we also plan to look at.
Okay, and just another comment, thank you. And with regard to the large fold difference in half-life that you noticed, have you considered any sort of genetic polymorphisms about those individuals that could potentially contribute to basically their elimination?
Oh, yes. But it takes money to investigate.
Do you have any thoughts about which polymorphisms could be contributing?
No, I wouldn't do that. I wouldn't speculate on that. Also, it takes money, and it takes also, I would say, quite a large study base.
For sure.
Which means even more money.
Yeah. Well, thank you for a wonderful talk.
Thank you. Indeed, Christina, it was, I think it's very important to have these epidemiological studies going on, but we also learned that it's not, the interpretation is not so easy and straightforward. So we have to look at different types of studies anyway to make conclusions. But it's my pleasure now to announce the next speaker. That will be Ron Hogeboom. Ron is assistant program leader working on food contaminants in the University of Wageningen. He's a human nutritionist and toxicologist. He has contributed to the development of the DR Calyx work, specifically to screen dioxins in food and feed. He has a lot of expertise on dioxins, but also on other food contaminants, and is since 2012 member of the EFSA Contam panel, where he also is co-chair of the working group on PFAS. And I think this is what he will talk about in a minute. So please, Ron, go ahead.
Yes, thank you very much, and thank you for the invitation to give this presentation. also on behalf of EFSA, I asked their permission to show this with their slides. Yeah, as you already explained, my role in this opinion was being in the panel that eventually adopts the opinion, and also being in the working group, at least for the second opinion, being in the working group, and there was the co-chair, the vice chair, which has then to look at all the different aspects of the opinion and try to get to a coherence in that. So I tried to explain. It's not easy to explain what is it, about 200 or 300 pages opinion, but maybe you've all read it. And but I'll try to explain how we got from one step to the next step. Let's see if this works. Yeah, it's a bit slower. Yeah. There are actually two opinions, as you may have noticed. We had an EFSA opinion 2018 where we dealt with the request of the Commission to look in principle at 28 different PFASs. Yeah, this was quite a number of different compounds. We decided to first look at PFOS, PFOA. This was published in 2018, and then we plan to continue on the other PFASs and maybe link them to the PFOS, PFOA. So that was more or less the idea. Let's see, it's really slow. Or maybe point there. Yeah. In 2018, I think this was the first time a risk assessment was based on human data. Before that, all the opinions, all the risk assessments were on animal data. And also the previous one from 2008 from EFSA. We derived at that stage different health-based guidance values, so TWIs for PFOS and PFOA, because we were not exactly clear on the mode of action. Was that the same for PFOS and PFOA? That was particularly on the increase in cholesterol levels, which was then the most critical effect, but we also had a couple of other effects which were shown at similar serum levels. Then we had a consultation with a number of member states. At that time, we did not do public consultations. But we had a diversity meeting with institutes that already had done a risk assessment, and that's in the legislation that you have to do that. So we did that, and yeah, during this meeting, there were a couple of issues that came up, and one of them was, for instance, some doubts whether there could be confounding in this cholesterol increase. So we were asked to really look again in the next opinion that initially was only on the other PFAS, but we were asked to look again at PFOA and PFOS as well. And that was also explained in an explanatory note. And another new thing was that EFSA came up with a guidance document on mixtures, and we asked us to look again whether we could deal with these compounds in a mixture instead of just individual TWIs. So this is the opinion. These are also the people I should like to acknowledge, because these are the people in the panel and the people that were actually in the working group, and sometimes there's of course an overlap. But I should also thank all the people that work on PFAS, because without the data, without the studies, we cannot do a risk assessment. So EFSA is not doing their own studies. It's really depending on what's being provided by all the scientists and the member states in terms of analysis. You may recognize some of the people here. Tanja Schwertler was actually the chair of this working group, and Dieter Schreng is the chair of the content panel, and then the others are in there. What we know about PFAS effects in animals, you see effects on liver. Also, the NTP studies show that at high doses. So that was always the most critical effect, I think. Increased liver weight, steatosis, necrosis. Decreased thyroid hormone levels at these high levels. There's the competition with transthyretin for the binding, so that may be a mechanism behind that. There are developmental effects, and I think a particular one I would like to point out, I already did this morning, is the mammary gland development, which has been shown in animals, but needs more work, I think, because it's shown at very low levels. So I think that's a very interesting endpoint to look into, and the relevance for humans as well. There's a decreased immune response, already mentioned several times today. Various studies showing that, and this is the study that was shown briefly by Thor. This is a study by Peyton Adams, which is the one that showed at the lowest doses already an effect. There are some issues, there are also other studies which show effects at higher levels, but yeah, maybe there are also methodological differences that could explain this. So this is worth looking at, but this is the one showing the lowest NOAA. And actually in the study, if you look at the paper, there's only one study reported, but actually there was a repeat and we asked for the data. And so this is the first time we can also show the results of the second study that was done. And this is all in the opinion, so you can look at that. So it's very repeatable, and they also analyzed, and that's interesting, they also analyzed the blood levels and found that in this case the NOAA, which you see there, is 80 nanogram per milliliter. So that could have been a starting point for the risk assessment, 80 nanogram per milliliter for PFOS, if we had used this study. And yeah, if you use an internal dose at a serum level, you don't need a 100 factor, but we would only use a factor of 25. But still, it's easy to see that you end up with a serum level, critical serum level below 1, actually. So this could have been the alternative to using the human data. And then link, for instance, using RPFs, link other PFASs to this study. This study has already been mentioned. This is a study by Grandjean, which was, I think, one of the first showing this decrease in antibody titers for different compounds. So they actually compared the separate PFASs that were detected in the blood. And yeah, if you look at this, you can see that there is a decrease or negative association both for the PFOS and PFOA in this study. Then we start to use this approach, and we thought, okay, can we use at least the PFASs that were detected in the blood of the serum of the people that were in the study, and in practice you can detect these 4 PFASs very consistently in the studies. They are in principle 50% of the exposure, as I can briefly show later, but in practice the short chain PFASs seem to be eliminated and have a short half-life. So these are the 4 that are easily detected. Then we had the discussion, of course, on the relative potencies. There are no studies, also no animal studies that look at that compare the different compounds. Most studies look at PFOS or PFOA, and in some cases at others. But there are no comparative studies, which was a shame because we could then not use this and we had to assume equal potencies. This is more or less the default that is applied by EFSA in these cases, also for other compounds. So we think that there are similar effects for other PFASs. Why would a hepta that's in between the hexa and the octa not do this? But yeah, we simply didn't have the study to include them. So that's the major reason that we did not take into account the others. We could have, of course, looked at animal studies and look at much higher dose levels, but that was also not realistic. It seems very likely that these compounds may do things in a similar range or not that much different. So that was the reason that we focused on the 4. We also asked then, since we want to look for the 4, we asked Philippe to provide us with data on the sum of the 4. And actually, if you look at it, looks even better, I think, than for the separate PFASs. And from this study, we derived. You see here the deciles. So the people are put in groups. And then you see that there's a clear decrease with higher serum levels, and from this we would arrive at a no effect level, NOAC, of 27 nanogram per milliliter. And that's based on statistical significance. If you look at the next higher dose, you already see a 50% decrease. So you could argue that even the 27 is a bit too high, that actually the no effect would be lower. So this was the starting point for this study. And then there was a new study on infants that actually arrived when we were doing the assessment. And this was a study by Klaus Abraham, who wanted to see if he could reproduce the data from the study on the Fareur. And for this, he used samples that he had from a study that was performed at the end of the 90s, at that time focusing on OCPs, but there's organochlorine pesticides, but also on dioxins. In this case, there were 101 children involved. Most were breastfed, about 20 children that were bottle fed, formula fed, but they fitted into the data and they were included in the analysis. So they looked at serum levels of mothers, but also at infants, and these were taken at the age of 1 year. So that's important because we use that 1 year, but not all the children were actually breastfed for 1 year. So that's already pointed out that this could be an important issue to deal with in the future. They were analyzed recently then for PFASs. They had titers already for 2 of the vaccines, but the third one, diphtheria, wasn't analyzed as well. Since they had all the contaminants measured in the past, they could easily look whether there was a confounding, and they excluded that. So they saw reverse association, particularly for PFOA. They also looked for PFOS, but for PFOS it didn't work. They didn't show a significant decrease, but for PFOA there was the decrease in particular. And for this, they arrive at NOAA-X of 12, 17, and 16. So pretty much the same as the 27 that we already saw from the Grandjean study, and maybe the 18 from the animal study. So it's all in a similar range. And then we asked, of course, if they could also model the sum of the 4, and they did. And this is a bit complex graph that you can also find in the opinion. This actually shows that if you group the children again in quintiles in this case, or 5 groups, that you do see a shift of the titers to the left, so to lower titers with higher exposure. So the 5th quintile especially shows the clear effect. And they, from this study, calculate an NOAA-X of 31.9, so a little bit higher than the 27 from the Grandjean study. And this was initially in the opinion that we brought for public consultation, because that's the new procedure by EFSA, that all the opinions are brought for public consultation. So this was actually in that opinion. And then we were asked during the public consultation by several people to do a BMD analysis. They said, well, this is the standard by EFSA. We initially thought it was not possible. We asked again to the data providers because that's one of the issues. We could not get hold of the data, so they had to do it for us. And they did the BMD analysis. We were able to do a couple of controls on that. And from this BMD analysis, they actually found that the BMDL 10 would be 17.5. So it's a bit lower than the 30. It's about half. And this takes into account the uncertainty of the dose response a bit better. And that's why normally you should prefer to use a BMD analysis. There are some issues which I will not go into about this BMD analysis, but it worked, and it's not that much different than the NOAA-L. So in the end, we use this value for the risk assessment. If you go to the original study, and I split up these two because we then had to go from this serum level to what could be the exposure of the children. And to do that, ideally you use a PBK model, and there's a PBK model published by Lochisano et al. We actually had 2 models, one for the PFOS and one for PFOA. So not for PFNA, not for PFHXS. So we decided to group the 2 sulfonates. Can be debated, but we did. And then we grouped the PFOA and PFNA, and they had about equal levels at the age of 1 year. So that's important. And I personally think that, and if you look at the modeling, that at younger ages, this relative distribution would be different. There would probably be more PFOA than PFOS. And maybe that's a little bit behind the fact that the PFOS by itself did not show the association. And that could be looked at as well. And then the question is how to get to the critical levels in the milk, because for these 1-year-olds, we assume that the exposure to the breast milk is the most important source. So what you try to do is to see what kind of milk levels would lead to these critical serum levels. And that's actually what we did. And also these levels have already been shown today because they are used at 133 that you see below there. was actually used, is already being used to compare levels that are measured in milk to this level. So we calculated these for P4 and P4s, and then based on the ratio that we know between the plasma levels in mothers and the milk levels, which is 0.03 for P4 and 0.015 for P4s, we could calculate what are the critical serum levels in the mother. And that's the 6.9 that already was shown a couple of times today as well. So the 6.9 really comes from this. So it means that P4 has a higher transfer to the milk than P4s. The only thing is that at some stage, the mothers start losing P4s and P4, and that they also lose P4 to a higher extent than P4s during the lactation period. So at some stage, this has an effect as well. And that was taken into account into the modeling. And then you can go to this one that was also shown by Philippe, I think, this graph, where you can then look at the mothers. So you extend the period, you go up to 50 years, and we assume that the mothers an age of 35. And then you can see, okay, what is the intake by the mothers that would eventually lead to these kind of serum levels in the mother? And then you see the 0.19 nanogram per kilogram body weight per day for the P4 and the 0.44 for the PFOS, and then combine this 0.63 nanogram per kilogram body weight per day. And then to get the TWI, this is done the reference point to start with, point of departure in the past, we nowadays call the reference point. And then you can multiply. We prefer to have to spread a bit the exposure over a week or even longer, but at EFSA, we normally do it for a week for these kind of persistent compounds. So we derived a tolerable weekly intake. I see people deriving them back to the TDI, but don't do that. We have a TWI for a purpose, and this is really to compensate a bit that one day can be a bit higher and the next day a bit lower. Otherwise, eating fish can be a risk by itself. So that's important to spread a little bit over a longer time period. So multiplying that, you end up with the 4.4. We could have rounded, but we decided not to do that. So stick to the 4.4. So if you look, what should it do? The 4.4 should prevent that the body burden of the mothers becomes a risk for the newborns. That's actually what we try to do here. It's the same as for the dioxins, for instance, exactly the same procedure. Yeah, we think that it should protect against immune effects at higher age. But actually, there are not many data to support that. So this is certainly something to look at. And of course, the new studies on COVID-19 and also vaccination later on may help us to see if this level is really protective. We decided not to use any uncertainty factors because we think that an effect on vaccination response is a risk factor rather than an adverse endpoint by itself. So we could have applied more uncertainty factors to protect even more, but we didn't do that. We decided to stick to this. Briefly on exposure assessment, this is always based on levels that are provided by EU member states. So EFSA does not have a large laboratory to do that. That's not true. Some people think that, but I have to say that, yeah, I think many laboratories were still focusing on the old TDI, which was, of course, 100 to 1,000-fold higher. So there was no need to have very low LODs, LOQs. And I think also as a result of that, that most data are left censored, meaning that they are below these detection limits. And yeah, we really have to shift now from ppb levels to PPT levels to do a good job. This is what we normally do. We look at the lower bound scenario and upper bound scenario. The lower bound, we assume that non-detects are equal to 0, which is unlikely. And the upper bound is very conservative, where I assume that then it may be equal to the LOD or the LOQ. And then EFSA uses food consumption service provided by member states. They have a whole list, I think up to 30 or 40 different consumption surveys, and they combine the two, and then they end up with an assessment of the exposure. I think I will skip this one for the sake of time. Most important is that in the exposure, we also saw the short chain ones, which seem important, but in the end, as I said, in the blood, you only see the 4. So you can find this also in the opinion. And then this is the outcome of the assessment. So we always have 4 different ones. The first one is just looking at the mean exposure in the lower bound scenario. So assuming non-detects are equal to 0. And then, because you have different surveys, you get a minimum exposure, you get a maximum exposure, and then we have the different age groups in there. And if you then look and everything that is marked red is higher than the TWI, you see that all these, that many of these age groups, especially at the medium and also at the maximum, you see that they are higher than the TWI, meaning that even at the lower bound exposure, which is probably too low, that you already see that that there is an exceedance of the TWI. The one for infants is marked italics, because there, of course, we have a different principle that's already covered by the exposure of the mother. If you then go to the P95, so these are people eating, for instance, foods that have a relatively high level of PFASs, maybe fish, that kind of exposure, then you see that in the P95, the levels are clearly much higher, and that people with the high exposure very much exceeded the TWI. If you then go to the upper bounds, this is really unrealistic, we think, and that was also the opinion. So normally we always use the upper bound for the risk assessment, but in this case we had good reasons to believe that this is really an overestimation of the exposure, a large overestimation. So we decided to focus on the lower bound exposure. Reason is also the outcome of TDIs, the total TDSs, total diet studies, but also the comparison of the intake with the serum levels made us believe that the lower bound is much more realistic than the upper bound. And if you look at biomonitoring data, and I think that's very interesting in this regard, that these are the critical serum levels already shown. There was a huge inventory of all the studies that looked at serum levels. You can find that in the opinion. And actually, if you then look and you focus maybe on the 2.5 and the 8.4, which are a kind of the median of the means of all these studies, then you can see that these medians are also exceeding the critical serum level in the model. So that fits pretty much with the exposure being at the high side. So the median levels are in general above the critical levels. Which groups contribute most? And these are the last slides. The fish is by far the most important, even at the medians. So maybe at P95, it's even a higher contribution. Eggs contribute to some extent. And then, and this is for these pops, quite surprising that in this case, you also see some exposure from fruits and vegetables. And this is just based on a very limited study, which limited in this sense that they only analyzed a few samples with a very, very, very sensitive method. And most of the data we got used very high LOQ, so could not even detect these kind of levels. So whether this is an under or overestimation of the contribution of fruits and vegetables is not clear at this moment. And that's really needed now that we get more data on these. It is known from studies that fruits and vegetables can actually pick up some of these PFASs. So there are quite a number of studies showing that, and especially vegetables. If you go for P4, you can see it's pretty much the same, but here also the drinking water is an important source. So some work to do. Yeah, this already mentioned. I think we need more data on relative potencies. It's not that we think they're equally potent, but we had no other option than to use equal potency. More data, mode of action is, I think, very well needed. And in the field of exposure assessment, we really need more sensitive analytical methods. There's a lot going on now, also in Europe, within what we call the European Reference Laboratory. They're really trying to decrease the levels or the LOQs of the methods, which is simply a need nowadays. I think we have to go down to PPT levels, and that in that regard, if we get more data, we hopefully can decrease the uncertainty and narrow the gap between the upper bound and lower bound exposure. With that, it automatically stops. With that, I would like to thank you.
Thank you very much, Ron. I think it was very nice how you took us through with a comprehensive talk through this difficult but elegant way of working, which was, at least for Europe, very traumatic, I would say, because the low levels means that almost everyone is above these levels. So
yes, this is the case, and of course this has a direct consequence for the levels in drinking water, which are linked to the TWI. So I think it has a huge impact. Yeah, I agree.
Okay, are there some questions from here? Yes, Wieneke.
Should I use the microphone?
I guess so, yes.
Probably better.
Yes, thank you very much.
We have also here one.
He has to do it.
Okay. I have a question related to HBM for you project, actually. Eva earlier showed that we have an HBM study population mainly focused on teenagers, and we have boys and girls included in there. I was wondering if you have a suggestion what health-based guidance value we should use to interpret the risk also for the boys, for instance, included in this study population.
Yeah, that's an interesting question, because that's not something we do normally at EFSA. We base it on the most sensitive group. At least that's what we assume, and that's what we try to do. Use the most sensitive group. As I pointed out, there may be, this is the question whether adults and also teenagers are equally sensitive, or as young children, or if they are even more sensitive. I think we need more studies on this. So for the moment, we think this is protecting everybody, but we have to see in the future if new studies come up and show that this is not correct. But this is what we could do at the moment, and again, it's a risk factor more than an adverse endpoint. I think Toal also showed that it's not so easy to show that it actually results in more infections. Some studies suggest that, but this needs more work.
We have another question now. I think I managed. From what we have seen in the previous talk, where high half-life variation was observed, was that fact considered the modeling used to derive the serum and milk PFAS concentration relationship? Does the modeling address either geographic or genetic variation among the sample population? Would that be an effect?
No, the model assumes half-lives, I think about 5 years for PFOS and 2.3, I think, for PFOA. And sure, this is another uncertainty in the assessment, but maybe in the future we can do a probabilistic kinetic modeling, taking this into account. That would be a nice thing for the future. Yeah. So we didn't take that into account. It's difficult to do.
Thank you.
Tony, you want to ask something?
May I ask a question?
Sure.
You fitted a model where you added the 4 of them, giving them equal weighting. And I'm just wondering whether you thought of doing a sensitivity where you tried fitting different degrees of weighting for potency. I mean, perhaps the RIVM values, or perhaps just others, to test the sensitivity of that.
That would be very nice to try that, but this is one of the problems we have in the assessment. I'm not sure where it will go in the future. That if epidemiological data, it's quite often difficult to get access to them. So that would be nice to just get them in, and of course, in an anonymous way, but there's always quite some protection on epidemiological data. So we could not try different potency factors, and if it would improve. The only thing I could say is that Klaus Arbaum didn't see an association for PFOS. So I have a bit the impression that if you start increasing the RPF for PFOS, that the association also for the 4 PFASs may be lost. So there's a risk, but we have to see that. It would be nice to try that. Maybe try different sets. I understand that RVM will try this in the HBM4U work. So I think that's very well, that would be interesting to see how that works. And ideally also on the data of Philippe Vanchard to see how that would work.
Well, it is a relatively small population, so my hunch is that you would get slightly different values of the goodness of fit, but they wouldn't be much different. So it would be it would be hard to distinguish them. There wouldn't be a sharp peak of a particular one fitting better, my guess would be. Because the numbers are small and it's quite noisy data.
Yeah, that's true. If in human data, I think that's already a part of the issue, that the variation is quite large. So I'm really curious to see if it would improve the association if you start trying different sets and maybe start with the ones that are IVM derived, but also try other ones. I'm pretty sure if you could be forced to 0.1, then probably the association becomes better. But maybe if you then increase BFNA with 10, let's see what happens. Yeah, but this would be nice. But yeah, unfortunately, we don't have the data, so that is one of the difficulties. Also, discussions, I think, in risk assessment, how to use studies when you don't have the data. Yeah.
We discussed this with EFSA. Do you hear me, Ron?
Yes, sure. Yeah.
Okay. My colleague, Espen Butt-Johnson, who's a professor at Biostat, we suggested to EFSA using our data because we have the raw data from the FERRY study that was published in 2012. We suggested to use a latent factor in a structural equation model. And for some reason, that was lost, and EFSA didn't want to do that because that way we could use a loading factor statistically as a potency factor, letting the data talk. And that's one of my concerns about what EFSA did.
Yeah, that's true. But the question is if we should all rely on the original investigators, or whether EFSA should get the database to try things themselves. And with the ABAM study, there was actually a graph that we could extract to do our own BMD modeling and see whether we ended up with the same analysis, because that's quite tricky, and that you completely rely on the original investigators without being able to check a couple of things. So we have to see how to solve that. That would be nice.
You're welcome to come and check.
Okay, let's do that.
So many more things to do, that's for sure. Maybe we don't have that much time anymore, but Philippe, you had not a possibility to answer some questions, but I think you have the opportunity now to maybe make a small wrap up from this afternoon. Could you use some time for that? But we have only limited time, so we're a little bit late. Can we give the floor to you?
That's fine. I'm sorry I never got questions, but
they are all in the chat, and maybe you had the opportunity to look at them.
Yeah, no, I'm in StreamYard. I'm not on Zoom, so because I'm a special person apparently. So, but anyway, if the colleagues want to ask questions about my presentation earlier today, I'm very easy to find on the internet. I can see that every morning that I'm easy to find. But please send me your questions. I promise I will respond to you. What I wanted to do right now is to see if I can share my screen and let's see if it works. Select window or screen. Okay. Okay. PowerPoint show. Okay. All right. I hope you can see my screen now. Okay. So the key issues that we have identified at the HBM.
We see you, Philippe, which is also nice, but okay. Fine.
Okay, the key issues that we have identified at this part of the FLUOROS conference is first of all, we heard that presentation on the placenta endothelium assay that I thought was very, very useful, and it illustrated that in vitro approaches are highly powerful when we need to understand potency or interaction. So this is something we need to look at further. I also heard the word MOA, the mode of action, and this is something that's very popular with traditional toxicologists. And I'm sorry if I embarrass any of you, but there is also a movement to say we don't have to know all of the details of the mode of action. There are people who say key characteristics would be quite sufficient. And this has been shown with carcinogens and endocrine disruptors and other compounds that you can actually get very far using key characteristics from toxicology, including in vitro studies. And I think that that's an approach that we need to pursue in regard to the PFASs, because we don't have the time to look at these tens or hundreds or even thousands of compounds. So I also hear that people are saying that PFAS concentrations in the body are stable and that we can rely on blood concentrations. I'm still concerned that there may be deep compartments. I mean, we know that from other chemicals, first of all, the metals, of course, that there are deep compartments that have much longer half-lives than the half-life in serum. It could be that those short-chain PFASs escape the serum simply because they are not bound very much to the albumin. Maybe they escape into the liver, or maybe they escape elsewhere, so that we are not assessing the exposure accurately in the target organs that may also be deep compartments. So we also heard about animal studies that the exposure levels may be too high, and I think the tradition is that we compare serum concentrations. Perhaps we should compare target organ concentrations between animals and humans, because clearly serum half-lives in rodents are much shorter than they are in humans. And we need to learn more using appropriate exposure data. Oops. So, and what we heard again from Ronneby and from other places is that we need to be careful about cross-sectional studies or studies with short follow-up, because the exposure assessment is really the independent parameter, and therefore any imprecision in our exposure assessment is highly likely to bias the findings toward the null, meaning that we're not finding anything, even if there is something to find. So we need to emphasize exposure assessments. And of course, I would like to emphasize the developmental exposures that Ron also described so beautifully. So we have dealt with EFSA's TWI, and the exposure limit that EFSA defined is often exceeded. And the big question now is, what is the consequence? Should we just say, too bad? Or should we say, hey, this is a warning signal? We need to, number one, limit future exposures. Number two, we need to limit future uses of these compounds. And number three, we need to pay special attention to those people. I mean, there are all of these different consequences, and we need to figure out how to deal with that. And we are slowly trying to figure this out. And I think Europe is ahead of time in comparison with the United States and other parts of the world in regard to doing exactly that. We're somewhat behind the exposure assessment, but HBM for EU is rapidly catching up. My final question is, what about human milk? Because clearly the PFAS concentrations in human milk greatly exceed the WTI that EFSA has defined. But what's the consequence? I have discussed this with various colleagues, pediatricians and nutritionists and others, and they are very concerned that we're scaring mothers, young mothers, from breastfeeding because human milk is truly the best nutrition that you can get when you start your postnatal life. But it's also, I almost think it's perverted that we are doing exactly that. We're contaminating that ideal nutrition that the new babies are supposed to thrive on. And so we need to tell ECHA and others that when they approve chemicals in the future, they need to make sure that those chemicals that they approve for the market will not end up in human milk. So these are my comments based on the presentations today with the HBM for EU. I think it has been a learningful and very successful experience. And I will now turn over to Waterfire in Providence, where I can see that my friend Rainer Lohmann is ready to close the session. Thank you.
Well, a big thanks to Philippe, Geit, Maria, Jared behind the scenes, and of course the guys behind the scenes, because we had some minor issues, but I'm glad we got it solved through Zoom and Hoover and StreamYard. So a big thanks. It was a very good discussion and with a lot of fantastic talks, and certainly room for thought. We unfortunately have to finish this session now because we have to get ready for the next live session here in half an hour. So a big bonjour to Brussels. I hope you have a wonderful afternoon. And thanks to Philippe and Jared again. And with that, there's lunch over there. And in half an hour, we continue live here. Thanks, everybody.
Thank you very much. Also
Thank you.
from Brussels. And thanks to all the speakers, the audience, and also the technical persons who helped very well. It was quite an experience.